Thank you very much, Rosemary, and hello and thank you everyone for joining us for the next hour. I'm Danny McRae and I'm with the U.S. Environmental Protection Agency's Energy Star program. This is the third webinar of a three-part series on the most energy efficient manufacturing plants in the United States. And if you're just joining us, there's a trivia question on the right, which is asking you to guess how much energy it takes to manufacture 1,000 pounds of frozen fried potatoes, and how much energy it takes to assemble a motor vehicle. So take a moment to answer that. And the reason why I'm asking you this question is because today we're going to hear two presentations, one from one of the most energy efficient French fry manufacturers and one of the most energy efficient auto assembly plants in the nation. So to start off, let's see how much energy people think it takes to actually manufacture these products. So Rosemary, can you share the results with everyone?
Yep, I just shared them.
All right, I see them. So thank you very much. So starting with frozen fried potatoes, it looks like they're all over the board, but most of the people said that it takes around 4 million BTU to process 1,000 pounds of frozen fried potatoes. That's the correct answer. And for motor vehicles, it looks like most people also got the correct answer, which is it takes about 5 million BTU to assemble a motor vehicle. And I'm going to go to the next slide. And I want to put that in perspective for everyone. So everyone here has boiled water. It takes a little over 1,000 BTU to bring a gallon of water to a boil. And it takes about 1.5 million BTU to bring 1,000 pounds of water to a boil. And it takes about 3 times that amount of energy to process the same amount of frozen fried potatoes. And why do you think that it's so energy intensive, French fries? So before they're actually fried at a fast food place or your kitchen, it's because the potatoes are first blanched, which adds heat. They're then dried, that removes heat. They're fried again, that's adding heat. And then they're freezed, which removes heat. And one of our speakers is going to talk more about that. So the next time you're at a party and want to share some random energy factoid, you can explain why it takes so much energy to manufacture potatoes. And you can also share that it takes the same amount of energy to assemble a car as it does to process 1,000 pounds. And they both take a lot of energy, and that's why focusing on the industrial sector is important. It takes a lot of energy to make certain products, and in the U.S. manufacturing sector consumes more energy than the energy we consume in our homes, at work, or when traveling. And similarly, energy use in the industrial sector is the largest source of greenhouse gas emissions in the country. So that's why it's important to focus on energy. Now, not all frozen fried potato and auto assembly plants are going to use the same amount of energy for making their products. As you see here, some are going to use more, some are going to use less. And at Energy Star, we consider the manufacturing plants that are in the top 25% to be the most energy efficient plants in the nation. And our speakers today, they have plants that are all in this blue section, the top 25%. They're going to tell you what they did at their plants to get to such a high level of achievement. But first, you may be wondering, how does the plant know if it's energy efficient or not? And how does Energy Star, how do we identify these plants? Well, Energy Star has benchmarking tools for nearly 20 sectors that will tell a plant how energy efficient they are compared to similar plants. And these are all shown on the screen before you. These are all available in Excel and downloadable at energystar.gov/plants. So if you're in one of these sectors, if you were going to download one of these right now, you would be able to figure out if your plant is, how efficient your plant is compared to others. Here's a snapshot of one of those Excel spreadsheets, one of these energy performance indicators, and this is how it works. This one is for automobile assembly plants, and just to let you know, all the data shown on here is fictitious and it's just for demonstration purposes. But the way it works is a manufacturing plant will input plant characteristics production characteristics into the EPI. They'll also indicate how much energy they use over a 12-month period. And the EPI is going to say how much energy a plant with these characteristics would be expected to use. So if you look under site energy, under average, it's saying that a plant with this amount of production, these characteristics should use about 1.1 million BTU during a 12-month period. But it's also showing you that based on the energy data you put in for your plant, you're using less than that. You're using 900,000. So you are more efficient than what an average plant is expected to be, and that's why your plant would get a score of a 90. All these models are based on manufacturer supplied data, either for the development of EPI or to the U.S. Census for manufacturers. Now, plants that score 75 or higher can be eligible for Energy Star plant certification. So the first step is see if you get what your score is. And then because Energy Star certification is issued by the EPA, we will require for that data to be verified by a professional engineer and for the plant to submit an application. Now today, there are over 240 Energy Star certified plants in the country. This shows where they are. And collectively, they saved a lot of money on utility bills and avoided a lot of greenhouse gases. And today we're very excited because we're going to hear from 2 of those 240 plants. We're going to hear from the Nissan Smyrna, Tennessee automobile assembly plant and the Lamb Weston Park Rapids, Minnesota plant. So joining us today from these 2 companies will be Trudy Slagle, Senior Director of ESG Administration at Lamb Weston, and Stephen Duong, who is the Energy Manager at Nissan North America. So they're going to tell you what their plants did to attain such high levels of efficiency. And during their presentations, I would encourage you just listen to what they did at their plants and see if it's applicable in your plants or buildings. Even though they're talking about automobile assembly and food plants, a lot of what they're saying can be transferable to other kinds of buildings. So see if you can replicate what they've done. So now, enough of me. I'm going to turn this over to Trudy Slagle, who leads the strategic planning and implementation at Lamb Weston's ESG initiatives, and she'll tell you how their Park Rapids plant achieved Energy Star certification and how they're maintaining efficiency. Trudy?
Yeah, hi, thanks, Danny. Happy to be here talking about Lamb Weston and French fries. It's a favorite topic. Representing the Park Rapids plant, I'm going to start with a little bit of a company overview for those that don't know much about the frozen potato industry or Lamb Weston in general. So our company has been around for over 70 years. It actually started out in a little town called Weston, Oregon, when a gentleman named Gibbs Lamb, hence Lamb Weston, bought a rundown vegetable processing plant and renovated it. He was an inventor and brought to fruition the first high-speed process to cut potatoes at a high velocity, which then became industry standard. So, over our long history, we've now grown to become the #1 frozen potato processor in North America and #2 globally. There's really just 3 of us that operate on this scale. Speaking of scale, our global presence here, you can see we have 27 plants. This includes some joint venture partnerships with an organization over in Europe called Lamb Weston Meyer, and also this facility we're talking about today, Park Rapids, is a joint venture, which we'll get into later with a partner named RDO Frozen. So, we are selling products in over 100 countries. We are manufacturing globally. You can see down in Australia, we've got a facility. We're in Argentina. And it really brings a lot of expertise from a global perspective into the manufacturing of French fries. From a structure perspective, we have 3 primary business segments, or what we call customer segments. The global segment really is where we are servicing and supplying French fries to quick service restaurants like McDonald's, Burger King, Chick-fil-A, again referencing that, 1 in 3 large frozen potato processors, if you eat a McDonald's French fry, the odds are very high that you're eating Lamb Weston product, depending on where you're at in the world. Then we have a food service segment, which is really institutional suppliers and restaurants that are not in that top 100 from a size perspective. And then we have a retail business unit, which puts our French fries directly in the consumer's hands through grocery stores. We have our own label, and we also make products for some of the well-known grocery chains across North America. A little bit more about that food service piece of it, because we do spend a lot of time in our own label and our own brand selling to these food service customers. Again, we also interact with commercial distributors, but what I think is unique, especially on the food service side and also with our global partners, is the long-term relationships that we have. I mean, 28 years is the average length of that customer relationship, and some of them have been with us for almost 50 years now. Brings a lot of collaboration to the table, both from a product innovation standpoint, but also in sustainability journeys. So, we've been around 70 years. Our sustainability journey is not that old, but it's also not new. Over a decade now, probably about 15 years, Lamb Weston has been focused on sustainability, and actually efficiency work, can be found in some of the earliest inventions of the company when we were really starting to expand and get more sophisticated in potato processing. More recently, we've committed to a set of 2030 targets, including a 20% reduction in Scope 1 and 2 greenhouse gas emissions, which are the energy sources directly used at our facilities. And this is where Energy Star and the EPI tool really come in to play more for us as a business. Getting to Park Rapids specifically, the gold star why we're all here, at least for the French fry portion of it. This facility is located up in the upper Midwest potato growing region, so Park Rapids, Minnesota. In addition to the traditional French fries that you think of at McDonald's, the straight cuts and those types of fries, this facility also makes hash brown products and what we call formed products, where we're taking smaller pieces of the potato and making things like a roundabout or a tater puff, which some people also might call a tot. For Lamb Weston, it's a puff. So, a little bit about the product profile there. And the Park Rapids facility specifically is distributing to restaurants and grocery stores in the Northwest. I'm sorry, in North America, not the Northwest. So this site was actually constructed in 1981. Lamb Weston started doing business there in 1992 and became an official joint venture with RD Offutt Company to form Lamb Weston RDO, and that joint venture is still intact today. Provides a unique experience out there in Minnesota as our teams work together from the farming and manufacturing standpoint. Over the plant's history, there have been some significant expansions, including in the 90s. We added, first significant expansion in the 90s, and then other modifications, including modernization and energy efficiency work. So, over 40 years, this facility is still one of our most energy efficient facilities in our fleet. So Danny talked a little bit about the process. Here it is laid out for everybody to see. Believe it or not, starting with raw product all the way down to frozen in the cold storage, the journey of a potato into a French fry takes about 4 hours. So if we're bringing a potato in directly from the field into our process, 4 hours later, there's a frozen case in the freezer ready to go to customers. Within that time frame, a lot happens. So, we're sizing, we're blending the different potatoes to get the right mix for efficient cutting and hitting the right specification for our customers. We've got the cutting process. We do a number of different steps to look for defects and, food safety elements. There's a lot of inspection happening, washing, and then that par fry that gets the cooking process started before we freeze it. You can see by looking at this why our energy intensity tends to be a little bit higher. These process steps, converting a raw material into a finished good, takes a lot of power, mainly natural gas to fuel our boilers for heat and steam within the process, and then electricity. Our big draw there is our freezing process, and then things like compressed air and some other equipment needs that we have. So Park Rapids, again, Energy Star leader, efficiency leader, also a sustainability leader for Lamb Weston, and that history goes back a long way. So, this facility specifically has a state-of-the-art wastewater treatment facility that creates renewable energy for us in the form of biogas. Really helps from an energy efficiency standpoint on the natural gas side with that 18% offset of a fossil fuel with a renewable. We've got a lot of practice-based analytics going on at the facility with utility benchmarking tracked daily to make sure that those efficiency numbers really stay within the right parameters. There's been some great recognition for Park Rapids, 15 Minnesota Pollution Control Agency awards. Really, exciting for that facility, just tight operations. We have an internal sustainability awards program that Park Rapids has really been a leader in, being recognized, year after year for their project work. And then, of course, the 12 consecutive years of Energy Star certification, which in the potato industry, I think is pretty significant. The EPI has grown and matured since it first came into play, into use, and not all of our facilities that were Energy Star certified 5 years ago have been able to maintain that status. So, Park Rapids has done a great job in their facility and keeping up with pace of change for efficiencies. A couple ways that Lamb Weston uses the EPI tool in general. So, we've got that climate change goal, and really those natural gas, electricity, renewables are driving that footprint. And the EPI tool gives us another lever to pull when we look at performance of our plants, both from, their own personal energy performance, but also from plant to plant to do a comparison to say, okay, well, if Park Rapids is scoring 84 on their EPI and another facility is scoring less, how do we benchmark what the difference is and start closing those gaps? I have an example here of the frozen fried potato EPI. Numbers are out, but for Park Rapids, you can see how the information is input. We've got total potato input. That's actually taking the raw tons out of field, not the finished goods, which is part of the calculation. And then our energy inputs down here for this particular facility, it's electricity, natural gas, and occasionally we have some diesel fuel for backup generation for our boilers. Not very often, but when we do, that gets included. This tool also looks for the heating degree day value for the year of certification. So another step in the process is making sure that we pull that information in. Generates a score for us each year. In 2021, Park Rapids achieved 84. I think their highest has been 91. Over the 12 years, operating conditions can definitely impact energy efficiency. So it's great to be able to use the tool even to track performance from that perspective as well. So to the project work, I think really from a Lamb Weston perspective and in Park Rapids specifically, these three projects are demonstrating a combination of investment into the facility with equipment, but also continuous improvement on equipment that's already existing. So it's not always about bringing in something brand new. It also involves making sure that we're maintaining our systems correctly and looking for opportunities to be more efficient with the tools that we have. The first project I'll talk about, which really these three projects specifically originated a number of years ago when we brought a third party in to do an energy audit for us, which was very, very helpful in the overall process because they were able to really spend the time and put the expertise into identifying project work that we could then say, all right, here's what we're gonna implement to really maximize the benefit of these projects. So compressed air, this project involved consolidating and updating the compressed air system. So we use compressed air in various different processing steps. Our food quality monitoring, we have something that's called an automatic defect removal system, which sends a puff of air to remove out-of-spec products from the line. We use it in our packaging equipment and just general other equipment pieces of our process. So the old system had our compressed air in various different places across the organization. This project brought them into a central area, added a single low pressure system and a full flow dryer. The new master control system and monitoring equipment deliver consistent air pressure, which helps us be more efficient. We went from 110 PSI down to 90. We definitely had a lot of plumbing issues that were causing efficiency issues, so replumbed that in the centralization process. And then we implemented water reuse taking the heated cooling water, the water that cools the system, from those compressor areas and air dryers and put in a heat exchanger so that we could preheat water for use in additional processing steps. So, you know, a good amount of work there to get this project implemented. This one saved us over 700,000 kilowatt hours per year and continues to do so. Another piece of work that we did was with our refrigeration system. So the facility used to freeze potato products at a higher rate of 150 PSI, and this project really focused on reducing the condensing pressure. So that really delivered savings to compressor horsepower. So we replaced older technology valves and motorized valves, operating on, with motorized valves to operate based on cooling needs. You guys can probably tell that I'm not the technical mind behind all of these projects, but we've got really great experts on hand as well. So excuse my stumbling, but in addition with this project, we added piping and valving and controls to the compressor for operating pressure needs. One compressor in the system builds enough pressure to feed the whole system while the others are able to run at a low flow. Installation of VFDs, you know, VFDs are used all over the place in potato processing, really help to control the overall system. And the end result was going from that 150 PSI pressure down to really 120, 130 on average. And then the third project that has really helped move the needle from an energy efficiency perspective, referenced it, you know, our biogas system earlier in my presentation, but it was really focusing on that utilization process and making sure that we could maximize the fuel coming from that system into our facility, driving our natural gas usage down. So we added some additional equipment into the burner at the boiler. We reduced pressure and flow restrictions, and through that work, instead of sending a portion of that resource to flare because we couldn't bring it into the facility, we're now using 100% of it in our boilers versus natural gas. And again, that's that 18% utilization improvement ties directly to an 18% reduction in natural gas use. So, you know, project benefits, this work really, right after it was implemented, we were scoring at an 87 on the EPI tool. The investment came to about $970,000. There was a savings of $400,000 with an additional $200,000 in utility rebates, which brought our simple payback to less than 2 years. You know, those utility rebates become a really important factor in energy efficiency work, at least for our business. From a metric standpoint, that's 23,000 decatherms of natural gas per year, over 3 million kilowatt hours, and 4,000 metric tons of greenhouse gas emissions from a scope 1 and 2 perspective. And that is my piece of it.
Great. Thank you very much, Shruti, for talking about the history of your plant and some of the activities it did to improve its efficiency and to maintain its efficiency. Really interesting about the biogas product project. If anyone has questions, please put them in the chat and we'll try to address as many as we can after the next presentation. So now we're going to go from French fries to motor vehicles. And I'm pleased to have Stephen Duong from Nissan North America with us. And he's going to talk about how the Smyrna, Tennessee automobile assembly plant has earned Energy Star certification for 16 consecutive years. This means that it's been in the top quartile of energy efficiency for that time. So Stephen, take it away and tell us what the plant did.
Sure, thank you, Danny. So, just to give everybody a background on Nissan and its footprint in the U.S. and Canada, we've got 3 manufacturing sites, one in Smyrna, Tennessee, one in Canton, Mississippi, and a powertrain plant in Deckard, Tennessee, as well as 50 non-manufacturing sites as well. But the goals for Nissan, we just finished up with the Nissan Green Program, or we are finishing up Nissan Green Program 2022. But for the future, we're looking at a carbon neutral goal by 2050. That includes our product portfolio and our manufacturing process. So in the product portfolio, we're looking at trying to innovate in the battery world by trying to innovate through the solid state battery technologies and also our e-power technology. And then once batteries don't last forever, so also working on a battery ecosystem where we can reuse, recycle, resell, and refabricate batteries that are returned to us. We're also working on manufacturing process innovations to help improve our operational efficiencies and get us down to low energy usage so that we can make it a little easier to go green as well. Outside of the 2050 goal, we just also joined the Science-Based Targets Initiative in the Race to Zero and business ambition for 1.5 degrees Celsius for our 2030 target. Just to give everybody a little bit of background on the Nissan Smyrna plant, which is the focus for today. This is our first U.S. manufacturing facility, which began production in 1983. We produced the Pathfinder, the Leaf, the Murano, Rogue, Maxima, and Infiniti QX60 in that facility. We have a production capacity of about 650,000 vehicles annually. And as Danny had mentioned, we are 16 consecutive years certified for this facility as well. So just to give everybody a little rundown on the process. First, we have the stamping facility or stamping plant where we send coils of metal into the facility, cut those coils into sheets, and then press out parts, which then go out to the body assembly shop where all the metal parts are welded together to give the final form of the body, which then proceeds to head to paint, which is actually one of our area of high energy use. And that's because you have such strict requirements for HVAC of the process, and you also have ovens to help cure paint. So once it goes through that process, we have the engine monitor manufacturing. That's actually in a separate facility.
Okay, this is Danny Macra, the facilitator. Rosemary, are you hearing Stephen? It looked like he cut out on my end.
It does look like he's cut out, so we can see if he's able to join in a minute or so, and then we can go from there if he's unable to.
Okay, well, in that case, while we wait for Stephen, sorry everyone for the technical issues. I'm going to maybe go to a few of the questions that we have for Trudy, and then we'll jump back into this presentation. But Rosemary or Chris, if you'd be able to reach out to Stephen with the dial-in information, maybe he could join by phone.
Yep, that sounds good. I'll email him.
All right, thanks. All right, sorry again, everyone, but Trudy, why don't we received a few questions on your presentation, so I'm going to just jump into them, if that's all right with you.
Yep.
All right. So the first has to do with COVID. Could you talk a little bit about how the pandemic has affected efficiency or your ability to continue to implement sustainability projects?
Yeah, COVID was hard, I think, for us and the rest of the world, specifically with a food product that is highly dependent on customers going out to eat. We saw a big drop in our production numbers simply because we had nowhere to sell product. Restaurants were closed all over the world. We saw some growth in the retail segment and were able to adjust some of our facilities really on the fly, which is a testament to the professionals that work in those locations, to be able to funnel more production into the retail space, and fill that pipeline, which helped. But when production reduces in an operation like ours, it doesn't necessarily reduce energy and water use in the same amount. The machines are still running, the process is still going. So we did deliver some what I would call consistent energy performance, but not peak energy performance.
Right. Yeah. Interesting, because there's still going to be that base flow that's needed to support the plant.
Mm-hmm.
So another question had to do with dashboards or metrics at the plant. Could you talk a little bit about whether there are certain metrics that you would use for sustainability beyond the EPI score, and a little bit about how that's communicated to all the stakeholders in the plant?
Yeah, so it's twofold. We have an environmental manager at our Park Rapids facility, and actually at all of our facilities, that do on-site reporting at various different intervals. Some are doing it daily, some are providing updates to their teams on a weekly basis. They're looking at really things like, they talk about therms per pound or kilowatt hours per pound versus the EPI type number. So, those are communicated on screens in lunchrooms, at shift changes, in management meetings at the facility level. And then from a company perspective, we have a central reporting system where all of that data is entered. And, we're looking at the energy efficiency data, water use data, and then also that conversion into a greenhouse gas number. It looks like we've got Stephen back, so I'm going to be quiet.
All right. Well, thank you, Trudy. That was a short break. Glad we're back, Stephen. I was going to ask your colleague to present in 30 seconds. But yeah, let's jump back into the automobile assembly process.
All right. Sorry about that, everybody. Not sure what happened there. I wouldn't have. I actually had kept going without realizing that I had disconnected. So I guess, Danny, do you know where I left off at before I dropped off?
I think you just went over the stamping process. We could go to welding and then go through that, and then we'll jump into the efficiency projects.
Okay, cool. Thank you. So from stamping, where parts are pressed out, we go into the body assembly shop where all the pressed parts are welded together to give you the form of the vehicle body itself. And that body then goes to the paint shop, where it's actually one of our more energy intensive processes because you have such tight requirements for HVAC to apply the paint. And then also you have ovens in the area as well. From there, we go in the Smyrna facility. We don't actually do the engine manufacturing. That's done in our Deckard powertrain plant. But we go into assembly, where the dash, the carpets, seats, the engines installed, and the chassis, your general suspension, and everything else is put together. Afterwards, we go through inspection for quality checks, and then finally through shipping before it goes to dealerships across the country. So the question comes, how have we been certified for 16 years straight? How have we maintained it for so long? The for several years it was easy because there was a lot of low-hanging fruit that resulted in great projects. In the past few years, the question has become, well, how do we continue to find those that low-hanging fruit that's sitting there that has regrown, or what be it? So we started utilizing energy treasure hunts. There are 2 to 3 day events that are focused on low to no cost energy saving opportunities. These are teams led by the energy team that consist of shop maintenance, production, and engineering. And we also include wildcards from other shops. These are folks who are either completely unfamiliar with the process, who can provide a fresh set of eyes, or people who may be from a shop that's similar to the one that we're doing treasure hunt in, and they can provide insight into projects that they've done in their shops that could be applied to the treasure hunt, or they can take back ideas that we get in the treasure hunt to their areas. So these events so far in 2022 have resulted in 2,388 megawatt hours of energy opportunity identified, and over 4,000 million BTU of natural gas opportunity. So looking forward to implementing some of those opportunities that we identified throughout the year. Hand in hand with those, we also conduct compressed air brigades. For everybody who's unfamiliar with the process, compressed air is used almost everywhere in our facilities. Go from stamping to help press parts, in paint, how we spray onto the body, and in body and trim, we have a vacuum where we have to, or for lithosis, where we can easily move parts around. And there's also many other processes that require it as well. Teams go around with a Fluke i900, which provides a visual, not just the sound decibel, but actually provides a visual so you can see and easier find the leak in question. And then we tag the compressed air leaks while we're there. Any quick and easy repairs, for example, leaking disconnect fitting, or just a small section of hose, those can be repaired on the spot while we're doing the compressed air brigade. And then anything else, as far as identified leaks go, they're entered into our central maintenance management system as work orders that we can complete at a later date. So far in 22, we've identified an equivalent of 1,960 megawatt hours of annual savings. So those events have always been fruitful for us. Now, the last 2 events, the treasure hunts and the compressed air brigades, are focused on small groups, no more than 5 or 6 per team. So the question becomes, how do we reach the rest of the facility and the employees? Which case we came up with the idea of the Save at Home, Save at Work, and Flip the Switch campaigns. These were campaigns to challenge employees to find energy savings at home and at work, and the media that we sent out over TV, newsletters, and our driver seat phone application included relations between ways to save at home and ways to save at work. For example, open dock doors and leaving the door open at home, or for fun we did compressed air and compressed air leaks and related it to the volume of Goodyear blimps that you could blow up in a given time period. Results for those were actually, we saw pretty quick results. You can see in the bottom right there where we were missing target a little bit for the first few months of the year, and then as soon as we launched the campaign, we were seeing green. So it was a win for the team and a win for the facility. Outside of the Save at Home, Save at Work, we also started utilizing dashboards and scorecards. So this is a screenshot from from our energy management information system, where we tracked energy week over week for a shop so that they could see where they landed on the weekend and where they had landed the previous weekend to make sure that things were being consistently turned off or shut down as needed. So it gives everybody a little bit of visibility, whether it's general folks on the floor, because we could put these on the TVs if we wanted to, or plant management. Also developed scorecards that you can see in the bottom right there, where we took the energy performance for the weekend and compared it to a benchmark that we had, or a target that we had set of varying levels. Through the EMIS, we could also set customizable KPIs and then show everybody how they're running compared to budget and their cost per unit. For the future, we're actually looking for another energy management information system, but we'd like to add in more meters. I think everybody could always use more meters, right? And then we're also looking at metering other operations and providing some insight to any on-site suppliers as well. Now, how we track plant performance, one of our KPIs or key performance indicators is the Energy Star Automobile Assembly Plant EPI, where we enter in plant characteristics, record weather, and energy consumption. And from those, every month, we put together this chart where we track our MMBTU per vehicle compared to the Energy Star Efficient 75 percentile benchmark MMBTU per vehicle, and we also keep track of the EPI score. So this gives energy managers and energy engineers the ability to monitor our energy intensity and the EPI score, and that lets us figure out kind of where we're going to land before we apply for certification. And once scores start to trend downwards, we can use the EPI because it has a split between electric and thermal energy intensities and benchmarks. We can compare those to the actuals and try to figure out where are we missing electricity or natural gas, and then we can try and trace from there. And as far as communication of our results, we have internal and external. Internally, we communicate our CO2 emissions targets, which are operational improvement focused, and then also for our energy management system review, which we review our energy performance with executive management. And then we also have external, where we report for Energy Star certification, plant certifications, and Energy Star Partner of the Year as well. And then we also have our Nissan Green Program Sustainability Report. And that is all for me. Thank you.